Thank you. Okay. So my talk today is on-device machine learning with CoreML and CreateML for your next app. So my name is James. Thanks for the intro, Josh. This is actually my first meetup talk. It might be a little rusty, but bear with me. And it's also my first junior dev. Anyone else's first junior dev today? Nice. Awesome. As such, I have a small request for please no photos and recording other than the organizers one. I'd really appreciate that. Thanks. So a little bit about me. So my name's James. I'm born and raised in Melbourne, as we know, Australia's best city. I'm 19 years old. I've been programming since I was 6. I've won 3 scholarships to Apple's Worldwide Developers Conference. Previously, I just finished up an internship there in the machine learning platform and technology team. And I've also mentored a few Swift courses at RMIT Online, so I might see a few familiar faces from there as well. Great, so let's talk machine learning. So at Apple, there's a lot of machine learning in the operating systems, and this machine learning leverages the powerful hardware, including the Apple Neural Engine. Some examples of this are the QuickType keyboard, watch replies, Face ID, and photo search, to name a few. But as developers, we often want to create our own ML experiences. So when we're creating our own ML experiences, where do we start? The best place to start is we should first ask ourselves, do we need machine learning? So sometimes machine learning is not the answer. And we should ask ourselves, do we have enough data? Are there enough patterns to learn from this? And is it meaningful? And is it ethical to use machine learning? What happens when we don't have training data to represent all of our users? There might be some unforeseen circumstances, and this could have negative consequences on our users, so we should be really careful when designing our user experiences. So if we do decide that machine learning is the right approach, and we are going to do a machine learning approach to our application, one great way to do this is on device. So you might be asking, what does this mean? So this means that running inference and generating predictions all happens on the user's device. And the 3 primary benefits to this are that it's private. So there's no sending of any user data to servers, which is great for GDPR and other privacy concerns. It's fast, so there's no server latency, and it also works offline. And pretty importantly for a lot of users, it's free. So there's no mobile data cost, and additionally, there's no server cost for the developers. Yay. So let's look at how we create machine learning models. So when we want to get started, there's 3 primary ways that we can get started with machine learning on Apple platforms. There are other ways, but these are the most popular. So we'll start off with Cheery Create. So Cheery Create is an open source project with a Python interface. It does require setting up pip, virtual environments, and a Python configuration, but this is great if you've already kind of got your toes dipped in machine learning and you want to look at, creating machine learning in very few lines of code. We also have CreateML, which is a Swift framework and a macOS application. And this does require you to have macOS Catalina and the newest Xcode 11 installed. And I'm going to be talking more about this later on. And additionally, we also have CoreML tools, which allow you to convert from other machine learning frameworks such as TensorFlow, Keras, and Caffe, perhaps scikit-learn and XGBoost. But this does require you to actually train that model externally and then kind of convert it to run on your device. So let's jump into CreateML. So CreateML is template-based, and what this means is that you kind of select your end goal and then you leave the ML to CreateML. So if you give it good data, it'll produce you a very good model. So I'm going to go over some of the templates. So we have our first templates are our image templates. We start off with an image classifier template, which classifies an entire image. This is useful for saying, perhaps if you want to tell if you're eating a hot dog or not. Anyone who's seen Silicon Valley might know that reference. We also have the object detector. So this identifies the objects within the images and gives you bounding boxes, of which bounding boxes are made up of 4 coordinates. And this is useful for saying how many hot dogs are in the image and where are they. In our text domains, we have a text classifier. So this analyzes an entire slab of text or a paragraph. And this is useful for, say, giving you sentiment analysis, classifying what the action is or something like that of that entire text. And word tagger is another text template, which is useful for identifying particular words relevant to your domain. For instance, if you were creating a medical app or you had a recipe, you might want to identify ingredients just based on passing in a sentence, extracting all that information. In the sound domain, we have sound classification. So this actually allows you to identify sounds in real time, as well as analyze sound files. So this is useful for, say, if you have a museum or a park, or you're building an app for someone in that particular domain, and you want to know, what is the sound that I can hear, etc. And in the motion domain, we have activity classification, which is really cool. It allows you to identify activities and motions based on gyroscopic and accelerometer data. So this is useful for Apple Watch, perhaps iPhone or Apple TV remotes, you can actually say what throw or exercise is the user doing in, say, a workout or fitness app. And last but not least, in our tabular templates, we have the recommender, which recommends items to users based on the similarities of items and the user's ratings. So this is, say, if you're building an app like Netflix, want to recommend movies or something of that kind of nature. And the tabular classifier and regressor predict values based on tabular data. So let's jump into a demo. Awesome. So I've launched Xcode, and I can simply launch the CreateML app by clicking on Xcode and open developer tool. CreateML. Great. And pressing new document allows me to create a new document. As we can see, these are the templates that I just covered in the slides. So I'm going to go ahead and we're going to be creating an app for a kids game, which will actually identify animals. Have any of you seen Madagascar? Nice. All right. So let's go ahead and create our Madagascar image classifier. And I'll go ahead and save that. And so this is the main interface of the CreateML app. So we kind of start on the left-hand side here on the input tab, and we make our way over to the output tab. So on the input tab, we see our data inputs, and this is where we can supply our training data, and if we have validation and testing data. We can also specify some additional parameters and augmentations to increase the accuracy of our models and generate better training data. So I have my Madagascar images, for instance, Alex the Lion, Marty, Melbourne, and Gloria, and I have an other class as well, which I'll explain more about later. So if I drag this directory in, which contains the subdirectories of labeled images, you'll see that I have 5 classes. So the 4 main characters and 1 other class, and I have 75 total items. So this means I have 75 images across all those folders. So I can simply click the train button, and this will train a model. We'll see feature extraction starts, so we can see it's processing some images now, and once the training begins, we'll actually start to see a graph. And this kind of shows us how the models are progressing, and as we can see, it starts to converge, and we've got a really good training accuracy. We also see validation accuracy, and as you can see, these are really high values. For those not familiar with the terms, the validation data is effectively data that was sliced out of the training data to kind of compare the model against unseen images. In this case, it performed perfectly, but obviously with more data, perhaps you might have different results and with different data sets, etc. I would highly recommend everyone to have testing data as well that they use to compare all their models against. For the sake of time, I don't have one. So I'm going to jump ahead right to the output tab. And as you can see, I actually have a CoreML model file here, if any of you are familiar. And it's a tiny 66 kilobytes. So this means you can add it into your app, and it's extremely tiny. There's very little overhead. Perfect if you're trying to slim down your app and kind of deliver a lightweight experience. So I can simply drag in images. So I take my images with Alex. Let's say I grab one. Drop it in, you'll see that it predicts lion. What's also really cool with this app is that I can do this with continuity camera. So if I have my wonderful picture of Alex, I hope you can all see. Import this from my phone. Oops. So on my phone, I will automatically get a camera viewfinder. So I take a photo. You can also see the photo there. As soon as I type use photo, sweet. So you can see I took this from my, right in front of my laptop here, and the image came through. And we can do this for all of our other ones as well. So I'm going to grab, what we got? Gloria. Let's go ahead and try this one more time. Snap. Cool. And you can see it predicts hippo. So that's basically what we've done is we've actually gone ahead and created an image classifier, and that was done in no lines of code, simply dragging in an image and clicking one button. And we can also do this for sound. So if I go ahead and create a new project, I can do this for sound, and I can do, I have farm animals. Awesome. Similar to the images, I have a folder with farm sounds. And these sounds basically are just different, oops, you probably can't hear them. They're just different sounds of those animals. So I can simply drag that in. If I click train, it's also very quick as well. We start to see a graph and we get training And we can see validation accuracy of 93%, so it's pretty accurate. Now, this model is slightly larger than the other one, just given the nature of being sound. And we can do the similar thing that we did before of we can drag in audio to kind of get those predictions. Additionally, we can also record from the microphone in real time. So if I moo, we should see it's cow. If I go like oink, 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 you'll see it's a pig. Okay, waka, ka, 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 cow, and you see we go to fox. So we have that. So that's a sound classifier, and that was trained in only 2 seconds. So that's pretty cool. And that's how you can kind of start training these machine learning models for your app. You don't need to have the best MacBook. You can kind of do it on anything that runs Xcode, which is really cool. And so now we can actually combine these to create some really powerful ML experiences. So I've actually already taken these models that I pre-trained earlier as well, and I've created a simple game with this to demonstrate these capabilities. And I've called it Matahuha. Anyone who's seen the movie might get that reference. And so basically, if we go with a kind of, okay. So we have a very simple interface right here. We can basically play with camera only, or we can play with sound. Okay, so if I go camera only, we see in the top we have these are island points. There's a 30-second countdown, and it says show me a lion. So now I have to simply put it to the lion. It found a lion, so now it's like show me a zebra. I get a zebra. Show me a hippo, giraffe, zebra, and I have to kind of see how many I can get in the 30-second countdown. So we can kind of create these experiences. As you can see, this is a real-time machine learning experience happening on the device. It doesn't have to be happening in real time. Like, you can ask the user to take a single photo, and process on one photo, and I scored 5. Not bad. You're welcome to try it out later on as well. And so when we combine these experiences, you can use multiple models to create entirely new things. Obviously, like, a lot of people are like, oh, well, I want to make the next hot dog, not hot dog app. Great. But you maybe, what does a hot dog sound like? Do hot dogs have sounds? Can you predict a hot dog based on the way it's cooking, right? Oh, thanks. Sweet. So I have another version of the game, play, and this basically, what this one does is you show it an item. So I have farm animals. Don't need those anymore. I have farm animals, and basically when it sees the farm animal, you have to make the same sound. So oink, 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 we'll go pig, I get a point, moo, I get a point, and then waka, kaka, kaka, cow, and waka, kaka, kaka, cow, oh, wait, fox. Sweet. So as you see, like, you can kind of combine these models together, and you can create, really cool experiences with that. Okay, so we've trained the model now. So I'm going to jump back into my slides. Awesome. So let's talk about integrating machine learning. Oh. There we go. Let's talk about integrating machine learning. So we have what we call domain-specific frameworks. And these frameworks really help us to integrate machine learning easier, as they already contain a lot of the code for pre-processing and post-processing your data into and out of the model. So the first one is the vision framework. We have the natural language framework and the sound analysis framework. And what this also means is that, for example, in the vision framework, it does a lot. And so sometimes you don't have to train a model. There are already models that are pre-trained in the operating system that you can leverage. And they're actually really good, highly accurate models that are used all across the OS, for example, in the Notes app, for scanning documents, etc. These are kind of subtle things that you might not realize you're using, but these models are actually available to you. And the vision framework also allows you to run the core ML models that are custom through it as well, as give you things like image saliency, human and animal detection, etc. The natural language framework also has a lot of really cool features, including tokenization, and this is where you can do your word tagging. But similarly as well, you don't need to train up a model if you're just trying to detect names of places, people, or organizations, because this sort of thing is already pre-trained up in the OS as well. And I'd highly encourage everyone to check those out if you are looking at building an ML experience for iOS. Last but not least, the sound analysis framework. This allows you to do audio analysis in real time, as well as processing files that have already been recorded. So I recommend checking that out as well. And now I'm going to have a quick demo on actually integrating machine learning. Cool. Okay, so back to my trusty Xcode. So I'm going to create a new Xcode project, a single view app. It's going to be very simple. Madagascar demo 2. Awesome. And so very simply, I can import the vision framework. So because we're going to use the first model that we trained up. So I'm going to go ahead and open that one up. That was the image classifier. Awesome. So in the CreateML app, integrating machine learning into your iOS app is very simple. You simply drag core ML model out and drop it in, add it to your target. And if you click this, you'll actually see information about the model. So we see it's 66 kilobytes. It also generates a Swift class for you. So you don't actually have to go and write any additional code to kind of get started with machine learning and actually getting those inputs into the model. It'll generate a class for you. And if you jump into that, you'll see all of this available, which is really cool. So I'm going to go ahead and call this zoo images. And now I am going to have some boilerplate code here for some UI elements to bring up a camera. Cool. Awesome. And the bulk of the actual machine learning code is going to happen in this function, which is going to be called predict image. Oops. Cool. So to start off, we must get our core ML model. So we can do model equals zoo images. And this will give us an ML model, which we can use to run predictions on. And then because we're doing this through Vision, Vision has a wrapper that you use called VN Core ML model. So we can set that up. So we have VN Core ML model, which wraps around the Core ML model. And now we create something called the request. So the request is actually a VN Core ML request. So you're telling Vision that you don't want to use any of the OS pre-built things. You actually want to go ahead and use a custom Core ML model. And you kind of say what you want it to do once it recognizes something. So in this case, we're taking the first prediction and we're going to print out those results. And then you have something called the vision handler. So the VN handler, create this, and this is where you can specify, say, image orientation. If your app works in multiple orientations, you might want to send that to the model so the model knows whether to rotate the image before it runs inference. And you can also specify other options here as well. Additionally, you can perform multiple requests. So if you have multiple models, maybe you want to see if it's a hot dog, and maybe you want to see if it's a, what type of hot dog it is, or is it a Frankfurt, or is it, pork or beef, that kind of thing. So you can kind of run multiple models here as well. And you can do that. So I'm going to go ahead and add the privacy entitlement so we can access the camera. Machine learning. Awesome. So I'm going to run this on my phone. Awesome. So I got the camera prompt. I can take a photo now. So if I take a photo of Marty here, we'll see that it predicts zebra. That's currently printing out. So we'll see it predicts zebra with 99% confidence. That's that. So that is less than 100 lines of code. It's about 70 lines of code, including the UI code. But the actual machine learning code itself isn't many lines itself. So as you can see, it's very easy to actually add machine learning into your existing apps already. And that's kind of the ML section of that. Cool. Awesome. So additionally, there's a model gallery that's available as well. So these are models that are pre-trained by Apple, and they're really good, high-quality models for, say, drawing classification, or question answering, or segmentation. And I'd highly recommend that you check these out if you want a model that you can start playing with, or if you just want to jump into Core ML without having to go up and train a model. And there's also some really good resources as well on developer.apple.com. There's a machine learning subsite that I'd highly recommend that you check out, as well as reaching out to me. And yeah, that concludes my talk. Thank you. Any questions?